Welcome back, everybody. We're on sound today, and we're doing a couple different problems. We're doing some problems on harmonics, and then on beats, which is the sound you hear whenever something is out of tune. Some kind of a crashing between two things that are not quite in tune. So I've given you the formula here for harmonics. See, this is the frequency. And N is going to stand for the number of the harmonic. So if you were to have a string, this is a wavelength. Okay, remember a wavelength is going to be a sine wave up, then back down to the normal, down, and then back up to the normal. One wavelength would be this far. This would be 1 lambda. If you were having a string vibrating, it vibrates from a node where it doesn't move to a node where it doesn't move, and then the string kind of goes back and forth here. So a string vibrating is actually 1/2 of a wavelength. Same thing in an organ pipe or a trumpet or whatever. You're going to have the air in the pipe is actually going to compress here in a compression and then be open here in a rarefaction between the two. And this is only 1/2 of a wavelength. So when you do this, you're going to end up having 2L, because I'm going to have to double this, double the string or double the pipe, in order to find the actual frequency of that fundamental. N is going to be the number of the harmonic. Okay, so if you're going to have this is 1. So this is called the fundamental. If you have, say, a pipe with 2 on it, remember we did this with the strings the other day. Okay, with 2, you'll have, that's the first harmonic. 3 would be the second harmonic, etc. Okay, so you're breaking it into, in this case, 3, and then 4, 5, 6. Okay, so the first harmonic would have 2, the second harmonic 3, etc. So here's your formula, and then we'll solve for whatever it is. Melody puts a fret on her guitar string, causing it to vibrate with a fundamental frequency of 250 Hertz. So a fundamental frequency is first harmonic. Okay, so this is going to be it's fundamental, so it's going to be the first harmonic. We've got as a wave travels at 350 meters per second. So this is what we're going to use for sound today. So this is 350 meters per second, and then the length of the string maybe is what we're trying to find. How long is the guitar string from the lower end of the fret? So I'm going to solve for L, and then we've got 250 Hertz here. So I'm just going to solve for L, and when I solve for L, I'm going to have L equals NV over 2F, which is 1 times 350 to 250, okay, and 1 times 350, don't know what this extra 0 is, I'm crazy. It gives you 0.7 meters. So 0.7 meters is how long your guitar string is. Okay, second question. How far and in what direction must the fret be moved in order to produce a fundamental frequency that's twice as high? Okay. Well, if the frequency is twice, the string only needs to be 1/2. Okay, so that would be, I guess that's the answer, 1/2 as far. 1/2 as far to give you twice. Okay, I'm not 100% sure, but I think that's right. Okay, let's try 11. Fundamental frequency of a bass violin string is 1045 Hertz. Okay, so we have the same thing. We have F equals NV over 2L. Okay, we've got the frequency is 1045 and occurs when the string is 0.9 meters long. Okay, that's L, 0.9. How far from the lower end of the bass violin should you place your fingers to allow the string to vibrate at a fundamental 3 times this frequency? Okay, Well, you're going to have to find out what the here's the fundamental. And the fundamental is still going to be 1 if it's a frequency 3 times as great. So all the numbers are filled in. So we need to solve for this. We'll need to solve for V in order to simply do it at 6L. Okay, we have to solve for V. So let's solve for V. I've got 1045 equals 1. So I'm going to divide by 1. I'm going to multiply by 2. I'm going to multiply by 0.9. It gives you a speed of 1880 meters per second. Now I'm just going to do the same thing. Okay, I'm going to do F equals N V over 2L, and I'm going to have okay. So I'll do 1 again. I'll do 1881. I'll have 2, and then 3 times the frequency. So 1 times 18 divided by 2 divided by 3 times the frequency of 1045. And that's going to give me 0.3 meters. Okay. Let's skip number 12. It's the same. You're just going to do another one the same. Well, let's do one more. And this is beats. This beats is actually very easy. If you're going to have a frequency of the beat, it's the difference from the 2 frequencies that I've got. So if you have a frequency of 2 beats and one vibrates at 392, what does the other one have to vibrate at? Okay. Well, it has to be 2 away. So it's going to be something minus 392 is 2. And so your other string is going to be 394 hertz. Okay, so you've got two notes, you've got beats. So what it's ringing at 392, but you're getting beats with a tuning fork. So how far must it be away? It must be 2 away, because that's what the beats are. Okay, I don't think I explained that well enough, but that's all you get today. Thanks.